Welcome to Solving Quadratic Equations by Graphing and Factoring Part 1. In this video we're going to focus on how to solve quadratic equations using a graph or a table, or possibly even both. So the title is long enough, so let's jump right in. Here we have the quadratic equation x squared plus 2x minus 3. And we are trying to find what makes this equation equal to 0. Now, when we are dealing with the graph, if we're trying to find what makes the equation equal to 0, what we are looking for is when does the graph touch the x-axis. So we want to find these 2 points here and discover what values of x are they, so that if we plug them into our quadratic equation, we end up with 0. Now, if you're given the graph, we can very easily see, oh, it's over here. We can look and see what x value that is, and over here, same thing. If we aren't given the graph, we're going to have to create a table and graph the function ourselves. So, to start off with, we want to find the vertex. The vertex is either the highest or the lowest point in our quadratic equation. And the way we find that is by using the expression opposite of b divided by 2a. Here, in our x squared plus 2x minus 3, our b value is 2, and our a value is 1. So, I can say the opposite of 2, opposite of b, all over 2 times 1 is going to equal negative 1. That is the x value of our vertex. So we have negative 1. Now we just have to substitute that into the original equation, and we have x squared, so negative 1 squared is a positive 1, plus 2 times negative 1, that's going to be a negative 2, so 1 plus a negative 2 is a negative 1, minus 3 is a negative 4. So our vertex is at negative 1, negative 4. And the reason why we want this vertex is because a quadratic equation graph is symmetrical. And if this is our lowest or highest point, we know that the values are going to go up from here or down from here. So we'll create our table. I have x values and I have y values. The vertex I'm going to put somewhere in the middle, and I'm going to go away from x a little, or away from 0 a little bit, so negative 2 and negative 3, and then I'm going to go towards 0 and past it, 0 and 1. And we'll see what happens with these 5 values. And if y is 0 in any of these values, we will know that we have found the zeros of our function. So to start off with, we know negative 1 is negative 4. If I try to find the function evaluated at 0, that means I have 0 squared plus 2 times 0 minus 3. Well then, the function evaluated at 0 is just negative 3. Now, that wasn't a 0, so I gotta keep trying. Let's see what happens at 1. The function evaluated at 1 is 1 squared plus 2 times 1 minus 3. 1 squared is 1, plus 2 times 1 is 3, minus 3 is 0. I found my first 0. Now I need to go the opposite direction and see where the other 0 comes from. If I do the function evaluated at negative 2, I have negative 2 squared plus 2 times negative 2 minus 3. Negative 2 squared is 4. 2 times negative 2 is a negative 4, so these cancel each other out, and we have negative 3 as our value. Now if we're noticing a little pattern here, we'll see that, oh, I have -4, -3, and -3. 0 is after the -3, so this is more than likely going to be our 0. But we shouldn't take it for granted, and we should check. So I have the function evaluated at -3 is -3 squared plus 2 times -3 minus 3. -3 squared is 9. 2 times -3 is -6. And minus another 3 is a 0. 9 minus 9. So our other 0 is at -3. And those are our values. We have figured out the zeros of our functions. This function has a 0 at x equals 1 and x equals -3. Alright, we'll try one more example and then that'll be it for part 1. For our second function, we have x squared minus x minus 6. We are going to find the zeros of this function by creating a table and then using that table to create a graph. So first, we are going to do the same thing we did before and find our vertex. Our vertex is, remember, the opposite of b divided by 2a. So our b is a -1, so it's going to be a +1 over 2 times 1, which is just 2. So our vertex is going to be at 1/2. Now, I really don't feel like dealing with fractions here, and as this is going to turn out, our zeros aren't going to be fractions, so I'm just going to start our table with the whole numbers that surround 1/2. I'm going to have my x and my y's. I'm going to have 0 and 1 here because they are surrounding 1/2. I'm going to go to 2, -1, and -2. Those are going to be my spots for the table, and hopefully they'll be enough. If we need to expand the table, we will. So first we're going to figure out the function at 0. If I put zeros in for x, all I'm going to be left with is a -6. If I put in 1, 1 minus 1 is 0, minus 6 is -6. Substitute in 2 for x, we'll have 4 minus 2 is 2, minus 6 is a -4. And so far we have not found a 0. But I can tell from the trend here, I'm at -6, I'm getting closer to 0. Let's see what happens if I go to 3. If I go to 3, I have 9 minus 3, which is 6, minus 6, which is 0. We've hit pay dirt. This is one of our zeros, 3. Now that we've found the first one, let's go in the other direction to find the second one. -1 in for x, so -1 squared is 1. Minus a -1 is addition, so that's going to be +1. 1 plus 1 is 2. Minus 6 is a -4. And hopefully we see our pattern again, so we can estimate that this is going to be 0 as well. But let's check. -2 squared is +4. Minus a -2 is addition, so we have 6. Minus 6 is 0. We have our two zeros, and now we can use this data from our table to create our graph and see what it actually looks like. Now, we have at 0, -6. So put a little dot there. At 1, we have a -6. And those are the same because, remember, our vertex is at 1/2, so our vertex is somewhere between here. I don't want to figure out what it exactly is right now because I don't feel like dealing with decimals, so I'm just going to arbitrarily say it's about here. At 2, we have -4. And then at 3, we have 0. -1, we have -4. And at -2, we have 0. And our graph will look something like this. And there we have it. We have found the zeros using graphing. Come back for part 2, where we find the zeros using factoring and a method I like to call the diamond method. See you soon.